So these are some plots that I ran into R. I had fun. I'm actually, so there's this thing called ggplot2, and I just played around with this on this data set. So this is what it looks like. So this is the default regression that you actually run on this data set. So let's all pretend that it's been run on an infinite number of data, and that's actually the true regression function I'm describing here, right? So remember, we have this probability and statistics, we have the truth, and here we have data, and we're assuming that probability goes from here to here, and that stats goes from here to here, right? So that was our little circle. Let's pretend that I'm talking about the truth right here. Okay, so I first draw the blue line. This is the truth, and then I draw data from this blue line, and we'll see how we want to do this. But essentially, this is the line that you would see, and this is the standard deviation that I'm getting around this. Okay, so I'm getting some sort of variability issue. Of course, so this is the variability of the estimator of the line. But if I wanted to actually get a standard deviation, I would actually need to get some lines that go like this. Right, so that would be, for example, maybe some conditional quantiles, right? That could actually create all those things. You want to really think that given a value, there is a whole distribution that goes like this. All right? So that's the way you want to think about this. And here, this distribution is centered about this blue line. Of course, it's hard for me to display all this. I'll show you an example in a second how we can do this. Okay, so for example, if I look at the discrete case, here's what would the conditional expectation look like, right? So here, given capital X is equal to little x, there's only 4 values that little x can take. This value, that value, that value, and that value. So the conditional expectation, given little x, the regression function is just a function from number 1, 2, 3, 4, and gives you 4 number, okay? That's what my conditional expectation is. And the numbers is just the average of those dots on each column. Is that clear what this is doing? Okay, so if you forget what this blue line means, what the regression is, it's just really a continuous version of those 4 dots, right? If I started having points all around, like starting filling the gaps between those guys, you would transform this into a curve. Okay, and here again, I can do some conditional quantiles, some conditional variance, right? So here, each of those distributions here has a variance, has a quantile. We'll see that in a sec. Actually, for those, it's easy to represent. Actually, let's look at it right here. So this is a plot that actually plots the conditional density. All right, so given that a person is in age group 30 to 34, what is the distribution of the number of clicks? And you can see the density here. So the densities are going up. Okay, everybody knows what they're seeing here. Right, so this is just a plot of the density. So if I should really plot it like this maybe, or maybe like flip like this or something. But this is the x-axis. It tells me that there's a lot of clicks that are in this region. And then there's a long tail up for a large number of clicks. And they basically look all the same. Now those bars that I've put here are actually quantiles. There's 3 bars. The one in the middle is the median. The one on the bottom is the 25th percentile, and this guy is the 75th percentile. Right? So there's basically 25% of the observations that are above this guy, 25% of the observations that are below this guy, and 50% in between. Okay, so you can see there's 25% of the observations that are in this very narrow window right here. Okay? So it's just splitting the data into 1 quarter, 1 quarter, 1 quarter, 1 quarter. Okay? Everybody, any question about what we're seeing here? Yeah.
Well, just to clarify, there seems to be dipping below the 0.
Yeah, sorry, because that's an estimator. But if it was, yeah, let's pretend the 0 is right here if you want. Any other question? Okay, so those are just densities. Those are conditional densities. Now, this is not a plot that you will typically say. I actually had to pull it out to be able to plot this. Something that you will see that summarizes conditional distributions visually is something that is called a box plot or box and whisker plot. It was invented by John Tukey, whom I named my dog after. He must be so proud. And so this is what they look like. So those are those boxes. And who has already seen a box plot before? All right, so box plot is basically a visual way to quickly see what a distribution looks like. Okay, so let's look at this guy, for example. What a box plot tells you is that the line at the bottom of the box is the 25th percentile. There's 25% of the observations that are below this and 75 that are above this. This is the 75th, right? So 25% above, 25%, 75% below, which means that in the box, what is the percentage of observations? 50% of the observations are within the box. The thick line in the middle is the median. And then the whiskers here are basically, well, they're actually sort of, depending on what software you're using, but they're essentially telling you some sort of a probabilistic maximum and probabilistic minimum. So essentially, it's computing some values that you think is sort of extreme, and everything in below, you can see the dots are actually represented because they're thought of as outliers. They just the random variable looks too far from Gaussian, and so all those points are thought of outliers. And you can see a lot of dots, much more than you would see on a typical box plot, because this distribution of clique that I showed you actually has very long tails up. And so that's why you see so many of those. But as you can see, it's much easier to read a box plot than reading the density, right? So the box plot tells you that the thickness of the box is called the interquartile range, right? So it's just the difference between the quartiles, the first and the third quartiles, or the 25 and 75% percentiles. And you can see it's increasing, and that's a measure of dispersion, just like the variance would be. So you can infer from this that the variance is increasing as the age increases. Okay, you can see that the median is also slightly increasing as the age increases. Okay, and here there's so many outliers that it's probably a good idea to look at the median rather than looking at the mean. And you can see that there's more outliers for this age group than there's for other age groups. But you can see actually an upward trend, right? Okay, so this is one way to represent conditional distributions. But if I wanted to summarize it by one number, in this case, I would probably look at what? Conditional median, right?